Assalamu alaikum, everyone. Welcome to Mathematics with Shahab Yaqub. Now, exams are just round the corner. Today is Tuesday, and the exam is on Friday afternoon. So now it's a good time that we go across some of the major topics. I went over the topic of circle equation. That's one of the toughest. The second toughest one is transformation. We went over it. But today are some new strategies that you find it useful to decipher what the transformation is all about. And then we will be going over some of these questions from 2020 and some of the questions from 2021 to have a good overview of it. So now it would approximately be a 2-hour session. The first half, I should say, that is about reviewing the concept with worked examples. So concepts will be reviewed and worked examples will be done, and they will be on the lines of past paper questions. So they will be very, very important. I should say that they might be more important than the examination question itself. And then in the second half, that will be based upon this. That will be going over 2020 past paper questions, 2021 past paper questions. So you will find it helpful. So now let's start the game. And now let's first talk about translation. Now, first of all, keep in mind, let me emphasize it over and over again, that have a bit of patience, because we'll be talking about translation, we would be talking about stretch, and we would be talking about the third one, which is reflection. Now, when we talk about translation, the diagram shows the graph of two functions that differ only by a constant. Now, underline the main details. They differ only by a constant. Over here, the x squared term and the x term is the same. The only difference is that in the constant. This is 1, this is 4, there is a difference of 3. That means this one is the original graph, if I call it the OG graph, and this one is 3 units up. So therefore, these two graphs are parallel. That means the distance between corresponding points will be the same. Now, we will say the graph of y is equals to x squared minus 2x plus 4 is a translation of the original graph by the vector 0, 3. And this is the analysis that we have. When we have the graph of y is equals to fx plus a, it's a translation of fx by a vector 0, a. Because over here, you write the x coordinate, over here, you write the y coordinate, over here, plus a will give me a vector 0, a. And if it was like this, fx minus a, then the vector would be 0 minus a. So plus a means graph moves vertically up. Negative a means graph moves vertically down. Focus on the translation vector, that is 0a. Focus on the translation vector, that is 0, negative a. That's the first basic thing. The next thing. Now what is done over here? We have x squared, but x is replaced with x minus 3. So this replacement is the game changer. This x over here, let me make it smaller. This x is replaced with x minus 3. This x is replaced with x minus 3. So now what you are getting is that the original graph, let me label this as fx, like the examiner uses the terminology, and this is gx. So the black one is fx, and this one over here, the red one, that is gx. So what do you observe? The turning point was 1, 0. Now the turning point is 4, 0. Instead of moving to the right, actually to the left, as you might be thinking, it moves to the right. So we don't have to understand the logic. The logic is given over here. We just have to understand the concept. So now the graph of y is equals to f bracket x minus a is a translation of this graph. Let me take this to the next page. And over there, I'll write it down. So now over here, when we have this thing, f of x minus a, so focus on this negative sign. And over here, that's a positive thing. It has the opposite effect. So horizontal things They have horizontal transformation. When we talk about translation, when we talk about stretch, which is coming up, they have the opposite effect. Remember this word, opposite effect. So now over here, negative A means it moves right, and the translation vector is A comma 0. And if this was f bracket x plus a, it's a translation of the graph by the vector negative a comma 0. So now let me write over here, negative a, it will, positive a, it will move to the left, and the translation vector would be negative a comma 0. Focus on the signs. This negative will give a positive in the translation vector. This positive will give me a negative in the translation vector, and vice versa. This is just an analysis that if we look at the whole thing, f bracket x minus a plus b, so negative a is positive, positive b is positive. This is for x-axis, this is for y-axis. Now let's look at some worked examples, and then I'll do few worked examples myself also. So now it says the graph of y is equals to x squared plus 5x. It is translated 2 units to the right. Find the equation of the resulting graph. Give your answer in this particular form. So now over here, what do we observe? We observe that they are moving 2 units to the right. So first of all, it will be of the form f bracket x plus minus h. Since it's moving 2 units to the right, so therefore right means negative h. That's the first thing. So now focus on the working. We have this x that is replaced with x minus 2. We have this x that is replaced with x minus 2, and that is how you get the equation. The next example. This time, there is a graph of 2 root x. It's translated by a vector negative 5, and this is positive 3. So now what is happening over here? This is 5 right. This is 3 left. So therefore, this negative 5, when written inside the bracket, is written plus 5, and plus 3, the y coordinate is written as plus 3. That's all about it. Now, when we look at this exercise, we have this thing, find the equation of each graph after the given transformation. So there are different things that they are asking. Sometimes they give you the original equation and they ask you for the new equation, that is the transformed equation. That is one kind of question. As you have seen over here, we have changed from original equation to transformed equation. We have changed from original equation to transformed equation. The next kind of question is that the original equation is given. So that is the original, that is the final. What do we have to find? The translation vector. Similarly, sometimes we have to sketch graphs. So sketching graphs is about coordinates. For example, if I focus over here, I'll be talking about this coordinate. I can be talking about this particular coordinate. I can be talking about this particular coordinate, this one, and last but not the least, that is this one. So it's a story of 5 coordinates, and each one can be transformed accordingly. And question 4 is more or like this. Question 5, 6, 7, that is slightly different. So now let me show you working for few of them. For example, if I look at this question, for example, question number 1A. So if I look at 1A, what does it say? By a translation 0, 4. So y is equals to 2x squared plus 4. That's the answer for A part. That is very basic. Now, what about part E over here? So now the translation is minus 5. Therefore, y is equals to 2 over minus 5 means write a plus 5 at the bottom. And similarly, if I work out h, there is both of them. So therefore, y is equals to 3 something square minus 2. And then this plus 2 over here means you should write a negative 2 over here. And this plus 3 over here means you should write a 3 on the outside and x will go over here. So the most important part is this one because it's a combination of both of them. Is this all good, all clear? So now simplify it further. That is 3x minus 2 whole square plus 1. That is the final equation. So now original equation is given. Apply the translation vector, find the final equation, the transform equation. Something like this. For example, question number 2a. So if I focus on a, y is equals to x square plus 5x minus 2, it's becoming y is equals to x square 5x plus 2. What is happening? This negative 2 is changing to plus 2. These two terms are the same. That means there is a translation vector and it's vertical because only the constant is changing. So from minus 2, you're getting to minus 1, you're getting to 0, you're getting to 1, you're getting to 2. So 1 unit, 2 unit, 3 units, 4 unit. So therefore, this is 0, 4. That is the translation vector. On the other hand, if I focus on part C, y is equals to x squared minus 3x. And that is beginning, that is changing to y is equals to x plus 1 whole square minus 3 times x plus 1. And I think it's very obvious what is happening. Wherever there is x, we are writing x plus 1. Wherever there is x, we are writing x plus 1. Sometimes it would be as simple as this. Sometimes you just have to go a bit deeper into this. So now when we have this thing, over here, x is changed to x plus 1. Now, plus 1 inside equation, it means left. All good? So therefore, the translation vector is negative 1, 0. That is what is happening over here. So now something to do with the coordinates. I think that's pretty basic. Let me focus on this one. A cubic graph has this equation. Write in a similar form the equation of this graph. So over here, if I write the equation of this graph, what do I do? We have y is equals to x plus something. So x plus 3. And therefore, this is x minus 2. And this is x minus 5. Now, what needs to be changed? This is plus 2. That is 2 right over here. So write a negative 2. Write a negative 2. Write a negative 2. And then simplify. You get this cubic equation. Something like this. Question number 6. Now, question number 6, it's about this thing, which is the graph of x squared minus 4x plus 1 is translated by this vector. So now when it's translated by this vector, you have to change this thing. So therefore, what do? We first write y is equals to something squared minus 4 times something plus 1 and then something else. First of all, let me focus on this. This 1 over here, that should go over here, that should go over here, this 2 over here, that should go over here. Make sense? So now we will write x as it is, and plus 1 means write a negative 1 over here. Plus 1 means write a negative 1 over here. And plus 2, the y coordinate means plus 2. That is how this is written. Simplify. And this is x squared minus 2x plus 1. And then this is a negative 4x plus 4 plus 3. And this is 1 plus 4 plus 3, that is 8. And minus 2x minus 4x, that is negative 6x. And this is x squared negative 6x plus 8. So I think that is pretty basic that we have done. So now let me write on the group what we have done so far. So we have done a lot of translation. And is this all good, all clear? So the groups are there. And that is the first thing. Let me just check one thing as usual. And yes, the recording is all good. The voice is all good. So now over here, let me move to the next one, which is reflection. The diagram shows the graph of two functions. The first is x squared minus 2x plus 1. And there is a minus on the whole thing. So there is a negative on the whole thing. So this is y is equals to negative of fx. What happens? That is a reflection on the graph in the x-axis. That is pretty basic. And then the next one. Now over here, what is happening? Wherever there is x, let me make it thinner. So wherever there is x, we replace it with negative x. Wherever there is x, we replace it with negative x. When this thing has happened, what do you observe? You have this thing. This is the transform. This is the original one. This thing goes over here. This thing goes over here, something like that. And now it's a reflection of the graph in the y-axis. A basic example, and that is this thing. The quadratic graph, let me highlight, the quadratic graph y is equals to fx has a minimum at the point 5 minus 7. Find the coordinates of the vertex and state whether it's a max or a min for each of the following. Now, when we are reflecting in the x-axis, so what is happening? That is basic O-level transformation, 5 minus 7. And this is the x-axis. So basically, if it's below, it will move up. So the y coordinate changes sign. So reflection in x-axis, y coordinate changes sign, and it becomes a maximum point. Because the minimum will become a maximum. Got the idea? It was like this. It was over here, and it was a minimum point. So now when it's shifted, it becomes a maximum point. Then the other one, f of negative x. What is that? F of negative x is a reflection of fx in y-axis. So now if it was a minimum, it would remain a minimum. There won't be any change except the x coordinate changes sign. So 5, negative 7 will change to negative 5, negative 7. Also, let me write over here. If I have a point AB, and it will become A minus B. If I have a point AB, this will become negative A comma B. What is happening over here? Over here, this is reflection in x-axis. So y coordinate changes sign. Over here, this is reflection in y-axis. So therefore, x coordinate changes sign. Got the idea? And we should also remember that this first one is minus of fx. The next one is f of negative x. Now, again, there are some questions related with sketch. There are some questions related with finding the new equation or something finding the transformation. So let me try one from here. So this is exercise 2E, 2F. And I'll also share the images of the solution with you later on. So let's say if I have this thing, which is question number 2A, and y is equals to 5x squared, and we want to reflect in x-axis. And similarly, let me write this thing. X-axis is there, and let me write b first. That is y is equals to 2x power 4. That is reflection in y-axis. So y is equals to 5x squared, reflection in x-axis. Therefore, this is simply minus of 5x squared. That is the new equation. And similarly, a reflection in y-axis, y is equals to 2 negative x raised to power of 4. It so happens that this negative raised to an even power becomes positive. And this is x4, and this is 2, so that is 2x4. The same goes over here, reflection in y-axis, multiply the whole thing. Over here, reflection in x-axis, change x with negative x. Something like question number 3. So if I look at question number 3, what do I observe? So question number 3A, therefore, y is equals to x squared plus 7x minus 3 is becoming y is equals to, if I take minus common, That is x squared plus 7x minus 3. That is what I've done. So this negative on the outside, that means reflection in x-axis. Now, the next one is slightly more trickier. That is this thing, y is equals to x squared minus 3x plus 4. Over here, this is basically x squared plus 3x plus 4. So now the x sign is not changing because even if it was negative, squaring makes it positive, correct? So this is actually negative x whole square, and this is minus 3, the original one, into negative x plus 4. This has the occurrence over here. So this negative x is squared. This negative x is multiplied with this negative 3 over here, and 4 remains as it is. So that's how this conversion is. This one is what? This is reflection in y-axis. All good, all clear? Now let's talk about stretches. The diagram shows the graph of two functions, y is equals to x squared minus 2x minus 3, and now this whole thing is multiplied by 2. So now when this whole thing is multiplied by 2, what has happened? The roots are not changing. The roots are fixed. The x-intercepts are fixed. But the y-coordinate is changing. The y-coordinate is, let's say this is negative 4. This is negative 8. So when this is happening, y is equals to afx. Only y coordinates are multiplied by scale factor, stretch factor. This a is the stretch factor. Whatever is written, that is the reality. The graph of y is equals to afx is the stretch of the graph with the stretch factor a parallel to the y-axis. If the stretch factor is negative, it's a combination of what? It's a stretch and then a reflection in x-axis. Over here, now what has happened? Now x, let me highlight over here, not this thing, just hold for a second. This x is replaced with 2x. This x is replaced with 2x. What has happened? Now it has shrunk. So now this width has decreased. First, the roots were there, and now the roots are over here. So therefore, this is going this way, this is going this way. Now I'll write, when we have y is equals to f of ax, first of all, the stretch factor is the reciprocal. So remember the word reciprocal of coefficient of x. That is the stretch factor. And only x coordinates are multiplied by stretch factor. That is what is happening. Again, the same thing is written over here, stretch factor 1 over a, and so on. Now, let's do some worked example for stretching. Now it says the graph of y is equals to 5 minus half x squared, a stretch with a scale factor 4 parallel to y-axis. So stretch factor 4. So let me write it like this. Whenever it's parallel to y-axis, I'll write it like this. Stretch factor is 4. And find the equation of this resulting graph. So this is a 4 multiplying with fx. That's all you have to do. It's a simple multiplication of this whole thing. Now the next one, describe the single transformation. That is the one, find the equation. Over here, find the transformation. That maps the graph of this to this. Now over here, this is what should raise your eyebrows. That is, the y coordinate is unchanged. So therefore, this is not something like this, because otherwise everything would be changed. Over here, 5 was changed. Over here, 5 is not changing. What is changing? 3x is becoming 6x. X squared is becoming 4x squared. So it's not that this is multiplied by 2 and this is multiplied by 4. That's not how it happens. There is no such thing as this. It's a substitution. So basically what is happening is that we have 4x squared minus 6x minus 5. That is basically 2x whole square minus 3 into 2x minus 5. Now compare it with the original one, which is x squared minus 3x minus 5. Now focus on this. X over here. Let me change it. This x over here was replaced by 2x. This x over here is replaced by 2x. Let me draw the bracket, which I missed. And this 5 remains as it is. That is how the stretch is done. Again, the same concept. You can either play around with a sketch. You can either find some equation. You can either find the transformation. So which exercise is this? This is exercise 2G. Keep that in mind. Now over here, exercise 2G, if I focus on this thing, let's say question number 2. So now in question number 2, if I focus on part A, so let me focus on part A. This is a stretch parallel to y-axis, stretch factor 2. And let me focus on this thing. Part B, stretch parallel to x-axis, stretch factor 2. And this is also E, stretch parallel to x-axis, stretch factor 1/3. Now let's focus on these 3 parts first. So now part A, y is equals to 3x squared. Actually, let me just move to the next one. That is better. So let me move to this one. That is also stretch parallel to y-axis, stretch factor 3. So part B, we have y is equals to x cubed minus 1. This is of the format y is equals to afx. Multiply throughout by 3. The stretch factor is 3. Whatever is written, that is the stretch factor. So therefore, 3y is equals to 3 bracket x cubed minus 1. That is 3x cubed minus 3. That is the answer. What about this one? Part D and part E. So let me write D over here. Let me write E over here. The equation is this. Y is equals to 2x squared minus 8x plus 10. This is stretch parallel to x-axis, stretch factor 2. Therefore, replace, now this is the main thing, replace x with half x. That is the main thing. Why? Because look over here, which is written somewhere. Okay. So now if this is ax, stretch factor is 1 over a. If it's 1 over a, stretch factor is the reciprocal. Yani stretch factor, the reciprocal of the stretch factor is plugged in. Keep that in mind. So now coming back over here, what do I need? I write y is equals to 2 bracket square minus 8 bracket plus 10. And yes, x is there. Yes, x is there. But what is being plugged in? Since the stretch factor is 2, you plug in half. You plug in half like this. And then you expand and simplify. So that is 2 into 1/4 x squared minus 4x plus 10. And therefore, this is half x squared minus 4x. And this is plus 10 over here. That is the answer. Now, let me do part E. 6x cubed minus 36x. Y is equals to 6x cubed minus 36x. If you want, you can simplify it first. It is also stretch parallel to x-axis. This means x-axis. This means x-axis. And if it's parallel to y-axis, I'll write it like this. And the stretch factor over here was, I think, 3. Coming back to this. What is the stretch factor? Stretch factor is 1/3. Stretch factor is 1/3. Therefore, plug in 1/3 x in place of x, because that is what is happening. So therefore, this is 6 1/3 x. Actually, no, 1/3 is already there. My bad. Let me write it. So now 1/3 is there. Therefore, you'd plug in 3x. So this is 3x whole cube minus 36 into 3x. And simplify, and then you get the answer. So now let's go to the WhatsApp. Reflection is done. Stretch is done. And we did questions like equation, like finding transformation. And the basic thing, the sketch is also there, which is about the thing which is playing out with the coordinates. So just acknowledge if this is all good, all clear. And let me also look at the WhatsApp. Okay. So now this is all good, all clear. One other thing, this one over here in which you have to realize something. You have to realize that what is the transformation all about. So now let's look at part A. Over here, this is y is equals to x squared plus 2x minus 5. It's converted to y is equals to 4x squared plus 4 minus 5. Again, focus on the constant. This is unchanged. So it's not a throughout multiplication. Therefore, it's a stretch parallel to x-axis. And let me simplify this a bit so that you have a good idea. Not this, that's the original one. Leave it as it is. Simplify this. That is 2x whole square. And this one is, I think, negative 4x. I forgot the x. Minus 5. So this is 2x. So this is 2 times 2x minus 5. Now focus on this. This one x is replaced with 2x. This x is replaced with 2x. And now, yes, I can say the value is 2 over here. Therefore, scale factor is half. That is how this question number 3 is also done. Now, let's do one other thing. That is part B. That is y is equals to x squared minus 3x plus 2. This is changed to y is equals to 3x squared minus 9x plus 6. Over here, everything is changed. X squared is becoming 3x squared, negative 3x, negative 9x. Even the constant is changing. That means it's a stretch parallel to y-axis. The scale factor is 3, as it's very, very obvious. Now, here is the game changer. That game changer is the combined transformation. So this is transformation combo. And this is about a lot of things. Some new strategies are there, some other ways of looking at things, which we haven't seen earlier. So pay very, very close attention to what I'm going to do. This thing, this box over here, we are all done with that. When we use the term vertical transformation, it could be moving up or down. This is translation. It could be a reflection in x-axis because this is like up and down, above and below the x-axis. That is how it is. And it could be a vertical stretch factor A. This is vertical transformation. When we talk about horizontal transformation, it's the opposite of whatever is written on the left. Vertical translation up and down, this is right and left. So over here, I'll write right and left. And we know the rule. When do we move right? When do we move left? Reflection in y-axis. This is y-axis. Something from here will move over here. So that is a horizontal transformation. And horizontal stretch, and the factor is 1 over a, but we plug a over here. Be very, very careful. Now, this is the statement that you should focus on. When combining transformation, care must be taken with the order in which the transformations are applied. When two vertical transformations or two horizontal transformations are combined, the order in which applied may affect the outcome. So let me just write over here, order makes a difference. It could be a coincidence that such a combination is there in which it's not making a difference. But the general rule is order makes a difference. So now whether it's a vertical or horizontal, order makes a good difference. When one horizontal, one vertical is applied, so one horizontal and one vertical is applied, the order does not affect the outcome. So horizontal, vertical or vertical, horizontal, order, no issue at all. For example, if I do one vertical, that is reflection in x-axis, and then right or left, doesn't make a difference whether I do this first and this next, or first the translation, then this. Similarly, I do a stretch, a horizontal stretch, and then up and down. That's the same thing as up and down, and then do the horizontal stretch. Vertical transformation, now even more important. Vertical transformation follow the normal order of operations as used in arithmetic. That is inside out. If an equation is written, it's inside out. And over here, horizontal transformation follows, let me just write it over here. Horizontal transformation follow the opposite order to the normal order of operations, and we will talk about it. So now the orders are different. So now these are four main things. Now, this is the exploration in which they make you do all this thing. We are focusing on this. When two vertical transformations are there, the order in which applied, or two horizontal, this is already seen, does not affect the outcome. So let me just cut it from here and let me just paste it over here. Now, let me start with this. Vertical transformation, horizontal transformation, the analysis in my handwriting, that is over here. Now focus on this. So two vertical transformation. So two vertical transformation. So vertical transformation is what? Vertical transformation is like up and down. Vertical transformation, it's stretch parallel to y-axis, scale factor A. Vertical transformation is reflection in x-axis. So that is reflection in x-axis. So these are vertical transformation. We will now consider how the graph of y is equals to fx is transformed to the graph of a if x plus k. Now, what do you think? How should we proceed? We should proceed in this manner. This is fx, then multiply with a, and then add a k. So that is the normal order. So this is the normal order, and that is the order that we will follow because it's two vertical transformation. So it's vertical, vertical, that is what we are going to follow. So now over here, fx stretch vertically, factor a, multiply function by a, it becomes a fx, translate 0k. So if k is positive, it will move up. If k is negative, it will move down. So hold for a second. Vertical transformations follow normal order. For example, 2 fx plus 1. So what is happening? The first thing, this is stretch along y-axis, scale factor 2, and then we move the graph up by 1 unit, and the translation vector is 0, 1. Similarly, over here, gx, another function, it's multiplying with -3. So this is also moving up, multiplying with -3. That means it's a combination of vertical stretching and flipping. Got the idea? So it's stretching as well as reflection in x-axis. And then at the end, what do? We translate it up, and the translation vector is 0, 2. So that is the basic idea. All good, all clear. So now, first of all, let me write over here the vertical, HH, order makes a difference. Order makes a difference. That is the thing. And then VH, HV, order, no issue. That is all good. That's the same thing. And now combo of VV. What is happening? That is the normal order. So I'm writing it on the WhatsApp so you people can remember. And combo of HH. Combo of HH are opposite to opposition. No, opposition is not right. Opposite to normal order. Everyone has the liberty of acknowledging it. So it shows your activity over here. That's the first group, and that is the second group, and it's the third one. Okay, so now let's move on. The next one. Combining two horizontal transformations. So what have I written? Two vertical, two horizontal. Let me write over here. So this is two horizontal transformation. So now what are the horizontal transformation? That is right or left. that the stretch parallel to x-axis. Scale factor is 1 over a. And then over here, that is the y-axis, and this is reflection like this. Now let's consider the graph of y is equals to fx is transformed to fbx plus c. Now over here, first we will focus on this. So that is the main thing. First deal with this. Plus c means negative c over here. So first is translation. And then the next one is bx. Therefore, if x is multiplied with b, then the stretch factor is what? 1 over b. Replace x with bx, and that is how you get this final answer. This leads to the important result. Horizontal transformation follows the opposite order to the normal order of operation. For example, over here, let me get started. Over here, first, it's translation vector, which is -1, 0. Then, because of 2x, scale factor is 1 over 2. It's a stretch parallel to x-axis. So that is how things are done over here. Got the idea? Over here, what is happening? Translation vector is 3, 0. And then stretch factor 1 over 2 becomes 2 parallel to x-axis. So now first thing first, let me highlight over here that a stretch factor 1 over 2 parallel to x-axis. Stretch factor is 2 parallel to x-axis. And this one is right over here, +1, that is this. This is -3, that is +3. All good, all clear. Now, let's also look at some worked examples, and then there are some very important questions that are coming this way. So I told you earlier, so it would take around an hour. Right now, 45 minutes are done. We are done with 45 minutes. Let me drink some water. Now it says, the diagram shows the graph of y is equals to fx. Sketch the graph of 2fx minus 3. So 2fx, that is stretch, -3, that is also movement up. Basically, this is vertical, follow the normal order. From fx to 2, and then this thing like this. 2fx is a combination of two vertical transformations. Sketch the graph of 2fx. Sketch the graph of 2fx minus 3. I think that is pretty basic. The next one. The diagram shows the graph of y is equals to x squared and its image gx after a combination of transformation. Find two different ways of describing the combination of transformation. Write down the equation of the graph. Let's look at over here. So let's say there is a translation of 4, 0. That is a horizontal transformation, followed by a horizontal stretch of scale factor half. Replace x with 2x. That is, I just want you to focus. So the original equation is x squared. Now let me write down the equation. Have they written down the equation later on? Yes, they have. So if this information is given, how will I write it? So I'll first write y is equals to something. There is a square over there. And +4 means -4. And then this x is now replaced with 2x. So therefore, this is over here. That is 2x minus 4 whole square. That is the combination over here. So part A, that is the first one. This is x squared, x minus 4, and then 2x. And they have done for this particular one. I mean, the equation will naturally come out to be the same. So that is one way of doing this. Let's move on. Again, sketches there. And over here, what will happen? X plus 2 plus 3. So now it's a combination of horizontal and vertical. Order does not make a difference. So basically, +2 over here, A plus 2 means what? -2. 3 means 3. It's a translation vector, -2, 3. It doesn't make a difference if you move 2 units left and 3 units up. That we know from O levels. Or we move 3 units up and then 2 units left. It doesn't make a difference. So this is horizontal and vertical combo. Part B, this is stretch along y-axis. This is up. So this is the normal order, first stretch, then add. Something like this one. This is also the normal order, first reflect, that's a vertical translation, then add. So basically this is negative of gx plus 2. And what about this one? 2x minus 6. So first it's a translation vector of 6, 0. It moves to the right. And then 2 is written over here. So it's a stretch factor of half. All good, all clear? Now some graph question. You can take a screenshot, try it later. I'll share the examples. Now remember, the first hour is going to end. We have to do past paper questions also. Now, let me pause the recording. I want you to try this out. So this is the first time I'm asking you to try the question out. So get started. So now over here, they are asking us two parts. Let me write this as part A. Let me write this as part B. So for part A, they are saying the original equation is x squared. There is a stretch in y direction. The vertical means y. Stretch factor is 3. First is this, and then followed by a translation vector of 1, 0. And the next one, let me also write it down. There is a translation vector of 1, 0, followed by a stretch with a scale factor of 3. So now this is vertical, this is horizontal, this is horizontal, this is vertical. So now, first thing first, a stretch in y direction with scale factor this. What is the equation? Y is equals to x squared. So first of all, we will write y is equals to 3 times x squared. And then translation vector is 1, 0. So y is equals to 3 times x minus 1 whole square. Now remember this thing. First, let me just write it over here. And the original one is y is equals to x squared. Let me also write over here, y is equals to x squared. And let me first focus on this. So now this x squared was multiplied with 3. And then this x was replaced by, x minus 1. Similarly, over here, y is equals to x squared. First, the translation vector. So x is replaced by x minus 1 whole square. And then we multiply with 3, that is 3 bracket x minus 1 whole square. So now what is happening over here? X is replaced with x minus 1, and then the 3 is on the outside. Now remember the rule, if it's a horizontal, vertical or vertical, horizontal, order does not make any difference, order no issue. That is why the final answer is the same. Similarly, let me move to this thing. Let me try this question number 6. It says the graph of y is equals to gx. Let me just check the recording over here. So hold for a second. The recording is all good, all clear. So now it says the graph of y is equals to gx is reflected in y-axis. So there is part A. It says the graph of gx is reflected in y-axis. So it has to be y is equals to f of negative x. And then it's stretched with a scale factor parallel to y-axis, scale factor 2 parallel to y-axis. Write down the equation of the resulting graph. Now it's in terms of g. It's not fx, it's gx. So let me change this to gx. And we are changing y is equals to gx according to this and according to this. That's the first thing. Also, let me write the info for part B. So again, y is equals to fx. What things are happening? It's translated by the vector 2 and minus 3. So first, it's a translation vector of 2 and negative 3. And then reflected in x-axis. So that one is what? That is f of x with a negative on the outside. So that is what is happening. So let me just remove the y from here. Let me just focus on what is happening. So now the first thing first, if I talk about part A, that is part A, this is part B, this is y is equals to gx. Now, first of all, I'll write g of negative x. That is the first thing. And then what is the stretch factor? The stretch factor over here is 2. That's right over here, y-axis reflected in y-axis, that is this negative sign. So now there is a 2 on the outside. So this is y is equals to 2g of negative x. Similarly over here, this fx thing, first it's a translation vector. So therefore, y is equals to f bracket plus 2 means minus 2, minus 3 means minus 3. That is the first thing. And then its reflection in this y is equals to negative of f bracket x minus 2 minus 3. If you want, you can expand. That is minus fx minus 2 plus 3. That is the answer for this. So now this is all good, all clear. Now question number 8. Try this out. I'm waiting for your input. Try this out. Let me pause the recording. So now let's look at question number 8. It says determine the sequence of transformation for each of the following. First part, x cube is transformed into this. So let me focus on part A. X cube is becoming x plus 5 whole cube. And then x plus 5 whole cube is becoming half bracket x plus 5 whole cube. That is what is happening. So since it's a horizontal transformation, that's why I focused on this first. Actually, it's a horizontal and a vertical, so both things can be done. That's not an issue. So now over here, this one is a translation, and the translation vector is negative 5, 0. And then this one is a stretch, and this stretch is parallel to y-axis, and whatever is written, that is the scale factor is 2. That is the first thing. Let me write part B over here. That is y is equals to x cube. It's transformed to x cube is transformed to this thing. So now the first thing is x plus 1 whole cube. And then the next one is minus half x plus 1 whole cube. And then minus half x plus 1 whole cube minus 2. There are 3 transformations over here. The first one is again a translation vector. Plus 1 means negative 1, 0. The other one, it's a stretch parallel to y-axis, and there is negative also involved. So let me say the scale factor is negative half, no issue. It does the reflection by itself, reflection in x-axis. And then the third one, that is also a translation. The translation vector is 0 and negative 2. So that's how this thing is done. The third one, you can also do it yourself. Now question number 9, the most important one. Question 9 and 10 is a similar one. I'll show you 9. You can try out 10 later. Fx is root x. Write down the equation of image of fx after reflection in x-axis, followed by a translation, followed by another translation, followed by a stretch. So let me highlight 4 things. First, it's reflection in x-axis. Second, it's followed by a translation 0 and 3. And then there is another translation that is 1 and 0. So you can say it's a translation of 1, 3. You can combine the two. And then the fourth thing is this stretch parallel to x-axis with stretch factor 2. Why don't you try this out first and let me show you the step. And then I'll also do part B. So now over here, I have done 2 different parts on 2 different pages. Let's focus on the first part. There is a reflection in x-axis. So this x will be, this root x will have a negative sign on the outside. That's the first thing. 0, 3, a 3 will be added on the outside. 1, 0, it would be x minus 1 like this. And then parallel to x-axis with scale stretch factor 2, that means x will be replaced with half x. That is the knowledge. Look over here. That is the information that was given to us. So this was the information. Leave it on the sidelines. And how things are working out, focus on that. Negative on the outside, negative on the outside, negative fx plus 3, this thing as it is, plus 3. Then this same thing, and now x is replaced with x minus 1. So x is replaced with x minus 1. All good? And then last but not the least, this x is replaced with half x. That is how this thing is done. So I hope many of you got it all good, all clear. This is the first time, not exactly the first time. There are many other questions over here, but in this lecture, you are looking at this question for the very first time. One step after the other, just follow the instruction. That is the language, the word that you have to convert it into equation. It's a word problem. Second one over here. So now let me put this thing in a box again. That is the info. What is the info? The info is translation vector 0, 3. Then a stretch parallel to x-axis scale factor 2, then a reflection in x-axis, then a translation vector over here. So now let's focus on this thing. First thing first, this plus 3 is added over here. Then scale factor 2, therefore replace x with 2x. So replace x with 2x. That thing is replaced. And then there is a reflection in x-axis minus on the outside for the whole thing. I haven't opened up the bracket. And last thing, that is a translation vector, 1 unit to the right. That means negative 1 over here. So x, this x is replaced like this. And that is how this question is done. So there is also this question, question number 3. I have done it over here. That is the solution. I have done it over here. That is the solution. And that completes the first part of the journey. Also this question, there are 2 other questions, my bad. It says, find 2 different ways of describing the combination of transformation that maps graph fx onto this thing. So first of all, what I did is that x is replaced with negative x. That is reflection in y-axis. And then it's a negative 2. That means it's a horizontal translation. So let me write over here, horizontal translation, and the translation vector is 2, 0. Or you can do the translation first and then reflect in y-axis. So reflection in y-axis, that is a horizontal translation. And this thing is also a horizontal translation. In this case, they both are exactly the same. So basically over here, this is y is equals to root x. This is y is equals to negative root x. The turning point is 0, 0. It is shifted how many units? It is negative 2. And I think I shifted it the other way around. So this should be shifted this way. So let me just shift it like this. And this can be like this. Got the idea? So let me just erase this thing over here. Let me cut it. And this is the reflection that's shown over here. So that completes one part of the journey. Let me move to this one. And now we are on the past papers. So I think 1 hour, 5 or 10 minutes are gone. And now we are on the past paper. Let's look at each question. I think this first one, let me highlight it over here. So this first one is this thing. This is February, March 2020, variant 1-2, question number 2. The graph of y is equals to fx is transformed to graph of y is equals to 1 plus f of half x. Describe fully 2 single transformation. So first transformation is this thing. That is, it's a stretch parallel to x-axis. And the scale factor should be the reciprocal, that should be 2. And then it's a translation vector of what? 0 and 1. So over here, the same concept over here. And it is half x. Let me just correct myself. This thing over here is 2. It's a reciprocal. And the x coordinate is multiplied by 2. And then it's a translation 1 unit up. This is 0 and 1. So now this thing is done. Let me remove it. The next one, let me go over here. Now this is May, June 2020, variant 1-2. So let me write over here. That is May, June 2020, variant 1-2, question number 9. Now it says, state the ranges of F and G. So you can draw, you can plug in the values, you can find the range, and this range will be the opposite, but also multiplication by 2. The y coordinates will be multiplied by 2. I'll also show you the graph. This is the graph of fx, and most probably they will ask us the graph of gx. So first of all, it would be the opposite like this, and then it would be like elongated like this, something like this. The function hx is such that hx is g x plus pi. Describe fully a transformation that maps fx into hx. So first, fx will be transformed with a -2 sign and then a plus pi. Let's look at the solution. First of all, over here, we know that sine x has a maximum value of 1, minimum value of -1. When -3 is applied, that is -3, +3, +2, this is -1 and 5. Because of the negative sign, things are flipped up. So this goes like this. And where we usually get a minimum, we are getting a maximum. Where we usually get a maximum, we are getting a minimum. Now, why? Double of that, but the signs change. So 5 becomes -10, -1 becomes +2. The graph, first of all, this is the original graph. That is the transform, just the reflection. And then the reflection is doing what? And then the reflection is being doubled. So this one is 2fx, just to give you the idea. This is 2fx, and then we reflect it in the x-axis. Or someone can draw -x and then double it. What about the transformation? We are interested in the transformation fx onto gx, stretch parallel to y-axis, scale factor 2, then reflect in x-axis. You can even write this thing combined. This and this combined can be written as stretch parallel to y-axis, scale factor -2. That serves the same purpose. And there is a plus over here, horizontal translation of pi units to the left. The translation vector is this thing. So now this is also done. Whatever is done, I'm removing the favorite sign from there. Now let's focus on this one. So now this one is May, June 2020. This is May, June 2020, variant 1-3, question number 3. A very frequently asked question by a lot of people. In each of the parts A, B, and C, the diagram, the graph shown with solid lines has equation such and such. So in each case, fx is the solid line, that is the solid line, that is the solid line. And then it says the graph shown with broken lines is the transformation of fx, let's call it gx. So how is fx converted to gx? State in terms of f, the equation of the graph shown with broken lines. So it's a reflection, as you can see, it's a reflection in y-axis. So we write f of -x. The answers are upstairs. We'll soon go over there. Now over here, what do you notice? Let me make it thinner. You should notice the vertical change between two corresponding points. Let's say this is the vertical and this is the horizontal change. Now the horizontal change between these 2 points remain the same. Let me first mark the points. Let's say one point is the red one that goes over here. The other one is the blue one that is over here. Now the difference, the horizontal difference between the red and the blue remains the same. The vertical difference between red and blue has doubled. That means it's a stretch parallel to y-axis and scale factor is 2. So basically this is 2 of fx, that is what you're looking for. Now this one, the orientation is the same. it is translation 1, 2, 3, 4 units to the left. I'm looking at this point, and then 1, 2, 3, 3 units down. So -4, -3. -4, -3, we write a +3, we write a -4. This is 2fx, that's done. There are a lot of points that I took care of, but when I taught you right now, I just took care of the height and the base. Reflection in y-axis, f of -x. So this thing is also done. Let me look at this graph, have a good look first over here. And this is October-November 2020 variant 11. October-November 2020 variant 11. This is question number 4. Read the question first. It says in the diagram, the lower curve has this equation, which is y is equals to cosine theta. So that's one cycle, and there is 2 cycles in 4 pi. And then the upper curve shows the result of applying a combination of transformation. They did not mention how many. Find in terms of cosine function the equation of the upper curve. So the first thing that I observed, that instead of one cycle, this is half a cycle. So therefore, it is like a stretch along x-axis. Scale factor is half. Therefore, we replace theta with 2 theta. So replace theta with 2 theta. That's the first thing. And over here, actually, let me just wait for a second. So let me use the period thing. So new period for this thing is how much? That is 4 pi is the new period. Let me just use this formula. This is better. New period is 2 pi over the coefficient of x, which is k. 4 pi is 2 pi over k. Therefore, k comes out to be half. So the coefficient is half. The stretch factor is 2. So do not mix up the things. So we will write a cosine of half theta. Got the idea? And then what is happening? Now focus on the upper, the maximum value, the minimum value. This is 1, this is 5. The difference is 4. Therefore, amplitude is half the difference, which is 2. So therefore, there should be a 2 over here. But the maximum value is not 2. The maximum value has been raised up 3 units. So this is 2 cosine half theta plus 3. So this is 2 cosine half theta plus theta. It's not theta, it's 3 over here. So that must be during some live class. This is all good, all done. Now over here, let's move on. This particular question, it's part of this thing, a big question. And now let's focus on this. Now, this is a standalone question for 2 marks. It says there are functions f, g, and h. First, fx 3 cosine 2x plus 2. So that is the original one. So this is the original function. That is 3 cosine 2x plus 2. Now, what is happening? How is fx becoming gx? They're not talking about hx. So now 2x is there. F of 2x. So now the x will be replaced with 2. And then there is a 4 over here. So now stretch it along x-axis, and the stretch factor should be the reciprocal. That is one thing. And then there is also this thing. Okay, so that's why 2 parts are there. Let me draw this over here. So there are 2 parts over here. This is part D. And this is part E over here. I can even take this down. So let me just take this down. Okay. Okay. Now, what is the first thing? The first thing is stretch parallel to x-axis by scale factor of half. Then it is shifted vertically up by 4 units. So translation vector is 0, 4. All good? Now, how will it transform from fx to hx? So now we are focusing on fx. We are focusing on hx. So this is x plus half pi. And then a 2 over here. So therefore, x plus half pi, it's shifted pi by 2 units to the left. The translation vector is this thing. and then it is stretched along y-axis with a scale factor of 2. So this thing is also done. Let's focus on this, something what we just practiced. Let me write over here. This is October, November 2020, variant 1-3. Express x squared plus 6x plus 5 in this form, where a and b are constants. The curve is transformed to this. Describe fully the transformations involved. So x squared and x squared is the same. Therefore, there is no stretch. 6x and 6x is also the same. No. Yeah, 6x plus 5 is there. So now there may be something to do with x-axis and something to do with what you call the translation. Now look over here. This is coming out to be x plus 3 whole square minus 4. This is ax minus h whole square plus k. A is positive. That is the shape. And minus 3 comma negative 4. That is the coordinate of the turning point. When we talk about x square, the turning point is 0, 0. The turning point is converted to negative 3, negative 4. So I can even write it directly. What is happening? You can write it as a combination of two things, two translation or one single translation. So it's along x-axis, that is negative 3 and then 4 units down. So now this thing is also done. And let's move to the other one, which is 2021, I think. Yeah. So let's start with this. February, March 2021, variant 1-2. There is only one variant. Describe fully the two single transformation which have been combined to give the resulting transformation. So now again, apply that rule which I told you earlier. Focus on this point, focus on this point. Focus on this point, focus on this point. Now, what you see over here is that this is like half unit. This is also half unit. That means there is no movement, no stretching along x-axis. Then there is 1 unit, then there is 2 unit, then there is 3 unit as opposed to 1 unit. So I see a stretch parallel to y-axis and the scale factor is 3. Why? Because it has increased 3 times. This is fx onto, let me call it gx. So fx into gx, this thing is there. Once this thing is done, there is also some translation. So first, let me take this point, which is over here. And let me take this point because I don't want the x coordinate to be 0, so that if there is any change, it won't be obvious. So this is 2, 2. And if I reflect, if I stretch it, what will it become? It will become 2, 6 because the stretch factor is 3 and it's parallel to y-axis. So now this 2, 6 is becoming 6, 6. So what is happening? This 4 over here, this 2 over here is increased by 4 unit. So therefore, the translation vector is 4, 0. That's how it's done. Double check. So over here, stretch parallel to y-axis, k is 3, translation of 4 units to the right, and 4 units to the right. There should be a negative sign over here, and then this 3 should be on the outside. So this thing is done. This is a very, very strong question that people have asked me a lot. This is about transformation, and this is also about solution. So let's have a look. The diagram shows the graph of y is equals to a tangent x minus b plus c. Minus b, horizontal shift b units to the right. C is vertical translation. A is the stretch factor. Given that b lies between 0 and pi, find the value of constants a, b, and c. Since the coefficient of x is 1, since the coefficient of x is 1, let me just double check one thing. It says tangent x, there are 2 cycles in 360, 1 cycle in 180. So there is 1 cycle. This is from negative 1/4 to 3/4. This is 1 cycle like this. That means this thing, the coefficient of x is 1. Why? This is the logic over here. This is the logic of y, because this is from 90 to 90. This is, that is one thing. So instead of 90, instead of pi by 2 over here, so this is pi by 2, and this is negative pi by 2. It has been shifted this way, this way. Again, the difference is the same. So 3 pi by 4 minus pi by 4 negative 3/4 minus 1/4. That is 3/4 plus 1/4, which is pi. That is the period over here. That is why the coefficient of x is 1. That's the first thing. Now over here, pi by 2 is shifted to 3 pi by 4. So now pi by 2, this pi by 2, this is pi by 2 is shifted over here. The asymptote is shifted to 3 pi by 4. Got it? So it has been shifted to the right. So therefore, pi by 2 plus b is 3 pi by 4. Therefore, b is pi by 4. Now you have a as 1. You have this thing, a as 1. Let me write it over here. And now plug in 2 points from here. So I chose 2 obvious points. This one over here, this one over here. I solve it simultaneously. I get the value of C, I get the value of A, because this is tangent. So it's better that you play safe and solve it simultaneously. So that is a very, very strong question. And let me save this thing with myself also, because people do ask this particular question. Okay, Ji. So this is done. Let's look at this. Over here, this is May, June 2021, May, June 2021, variant 1-2. Question number 2. It says the graph of y is equals to fx is transformed to graph of y is equals to 2fx2 bracket fx minus 1. Describe fully 2 single transformation. This is part 1. So let's focus on part 1 first. Fx becoming fx minus 1, shift graph horizontally 1 unit to the right. And also write the translation vector is 1, 0. Make a habit of writing it. Then the graph is stretched parallel to y-axis. And what is the scale factor? That is 2. Let's read this part now. Now it says that the curve y is equals to sine 2x minus 5x is reflected in the y-axis. That is the first thing. And then it is stretched by a scale factor of 1/3. They have defined the order, and then in the x direction, write down the equation of the transform curve. Now, if this was written as fx, what exactly would I be doing? Reflection in y-axis, so this is f of negative x. And then stretch by scale factor 1/3. Scale factor 1/3, therefore x should be replaced with 3x. So therefore, the next step is that f of negative of 3x that needs to be done. Try this out. The recording is still on. I'll just wait for 1 minute. Get it right this time. Let me check the recording and everything. And yes, it's on. A very simple question. You can do it in steps, and then I'll tell you the solution. So now, people, let's move ahead and look at the solution. The solution is right over here. Sine 2x minus 5x multiplied by negative 1. Multiply, my bad. This is reflection in x-axis. So this is reflection in x-axis. So 2x should be replaced by this thing. So therefore, this is multiplied by minus 1 over here. So let me just write it properly over here and over here. And then what you do is that you replace with 3x. I think let me do the working myself. That would be better. That one is myself, but a long time ago. So first of all, sine bracket. Let me change the marker. This is sine bracket 2 into negative x minus 5 into negative x. That's the first thing. So this is sine of negative 2x plus 5x. And we know this rule. Let me remove it. That is sine of negative theta is negative sine theta. So I can either leave it as it is or I can convert it. So this is sine 2x with a positive sign, sine of negative theta and sine of negative theta, because it's in the first and fourth quadrant. First quadrant, fourth quadrant, first quadrant, sine is positive, fourth quadrant, sine is not positive. So therefore, this is negative sine 2x plus 5x. That is the first thing, reflection in y-axis. So this all over here, that is reflection in y-axis. Now, what's the next part? That is stretch. So replace x with 3x. So negative sine. This is 2 into 3x, close the bracket, plus 5 into 3x. So that is negative 6 sine 6x plus 15x. That is the answer for this particular part. So now this thing is done over here. Let's move on. This question. No, this thing is done. So now over here, the functions f and g are both defined for this thing. So therefore, fx is this thing, gx is this thing. By first expressing each in the completed square form, fx express gx in this form. So fx is x minus 1 whole square plus 4. Gx is x plus 2 whole square plus 9. The turning point is 1, 4. The turning point is minus 2, 9. So 1, 4 plus pq, the translation vector, is giving me minus 2, 9. Therefore, p is negative 3, and this is this. So therefore, how would you change? You would do it like this. Negative 3, we write a positive 3, and plus 5, we write a 5. That is how gx and fx are related. So this is completed square form. This is the answer for the first part. Based upon that, I have also described it. That is shift horizontally 3 left, vertically 5 units up. Now over here, which one is this? This is completed square. Okay, hold for a second. Yeah. Read this part, which year it is. This is October, November 2021, variant 11. So let me write over here, October, November 2021, variant 11. The result of translating the graph fx by this thing is the graph of gx, express gx in this form. Now, do we have gx? We have fx. Fx is right over here. Let me do the working. Let me show you the working. So now fx is right over here, minus 3x minus 2 whole square plus 14. Now we are shifting our 3 units to the left. And then 1 unit up. And there is also this thing. So now the new turning point is this thing, minus 2 plus 3, that is 1 over here. And then 14 plus 1, that is 15. And don't forget to multiply by this thing. And that is how this thing is obtained. Now, this thing was part of a big quadratic thing. And this is the last part. That is how you work it out. The same process, the original thing, just change the coordinates, then open up the bracket. So now this thing is done. And let's look over here. This was a very nice question. It says the graph of fx is transformed to the graph of f of 2x minus 3. This is October, November, a very nice question. October, November 2021, variant 1, 2, question number 2. There is part A, there is part B. Part B is a star. F of 2x minus 3. That means fx is becoming f of 2x. It's becoming f of 2x minus 3. What is the first thing? The first thing that is happening is that stretch parallel to x-axis and scale factor is half. The next one, what is happening? Then there is -3. So this is a vertical translation, and the translation vector is 0, -3. Got the idea? That is the first thing. Let's double check. So over here, this is stretch along x-axis, scale factor half, vertical translation 3 units down. Make a habit of writing translation vector, which is 0 and -3. Y coordinates unchanged in this one, and x coordinate is multiplied by 1 over a, which is the scale factor. Now over here, let's look at this. The 0.56 lies on the transformed curve. Y is equals to this thing. So now state the coordinates of the corresponding point on the original curve. Focus on this. We have AB. It will change to something. It will then change to something, correct? So the first thing is what? That is stretch parallel to x-axis, scale factor half. A is multiplied with half. So this is half A and B. Half A remains as it is. And how many units are we going down? We are going down 3 units. So this is B minus 3. And now whatever the original is, the transformed one is 5 and 6. So half A is equals to 5. A comes out to be 10. B minus 3 equals to 6. B comes out to be 9. Therefore, the original coordinate is 10, 9. No harm in double checking. So we have 10 and 9. Half of 10 and 9. So half of 10 and 9. And then half of 10 is 5. That remains as it is. 9 minus 3, that is 6. That is 5 and 6. So I have checked it before the examiner checks it. So now this thing is done. Last question. The graph of y is equals to fx is transformed to the graph of y is equals to 3 minus fx. So first it's fx, then it's becoming negative fx, then negative fx, there is a 3 being added. So first thing, minus on the outside, flip y is equals to fx in x-axis, reflection. So flip, it means reflection in x-axis. And then it's translated vertically by 3 units. So it's vertically. So therefore, this is 0, 3. Let me write it correctly. And that's all about transformation. So I hope you found this lecture very, very beneficial. Let me know in the comments. Stay tuned for more content on Mathematics with Shahab Yaqub.